Hey, it's 12 o'clock, so we'll go ahead and get started. Thanks so much for joining us today. I'm Chloe, and I work with the Tri-County Regional Energy Network. And today we're joined by Ken Levinson from the Passive House Network for an introduction to the Passive House Standard. Ooh, Ken, can I have you actually pop back a few slides?
Oh, yes, I'm sorry.
No worries. I was admiring your slide. It's so
Yeah.
nice that I didn't even notice it was not the one I was looking for. So before I pass things off to Ken, before we get to his slides, I have a couple of quick logistics to go over today. And Ken, you can go to the next slide. Great, thank you. So a few quick Zoom reminders. We're going to ask that everyone remain on mute for this training just so we can all hear each other. If you have any questions, please either raise your hand if it's an urgent clarifying question, or you can pop it into the chat. Ken will also be pausing occasionally to take questions from you all, so you can wait for those opportunities to ask your questions as well. We are recording this session. The recording and slides will be shared with you in the next several days. You'll also be receiving a survey in your email inbox. This is a super quick survey. It really helps us out in terms of planning our programming. So if you attend this training and you really like it and you want to see more like it in the future, definitely let us know. It really helps us out. If you also have any ideas for other sorts of training you'd like to see us do, you can also tell us about that in the survey. We read all of the responses we get, and the input really helps us in planning our programming. And then lastly, we do have two AIA learning units approved for today. And if you want to receive those units, please make sure that you are registered for today's training and joining via the link you received when you registered. So if you're joining with someone else's link, a colleague shared a Zoom link with you, we're not going to have your attendance recorded. That's how we record the attendance. So just make sure it's what you've done. And if you haven't done that, go ahead and send it'll be Danica. I'll share Danica's email later. You're going to email Danica and she'll take care of that for you. Okay, and then we can go on to the next slide. Thank you, Ken. So we are the Tri-County Regional Energy Network, aka 3CREN. 3CREN is funded by ratepayer dollars that we all pay into in our utility bills through the public goods charge. And the benefit of being ratepayer funded is that there is no cost to those we serve. And as a regional energy network, we're able to return these dollars back to our local economy, which has historically missed out on some of these funds. We can go to the next slide. Thank you. Okay. And so 3CREN has 6 programs that are focused around 3 service areas. These include incentives, training, and technical support. Today's training is under the Energy Code Connect, which you can see in the middle here in training. To see more trainings and events and learn more about our other programs, please visit our website, 3c-ren.org. We can move to the next slide. Okay, and that's it. Hand it off to Ken. Thank you so much. And everyone, enjoy the training today. If you have any questions, please reach out in the chat.
Thank you, Chloe. It's great to be here with you today. My name is Ken Levinson, and I'm the Executive Director of the Passive House Network. And we'll spend the next couple of hours giving a pretty in-depth presentation, introduction to Passive House. Again, if you have questions along the way, because we'll build on the knowledge. So if there's something basic that you're not getting, feel free to put it in the chat. I'll try to keep an eye on it. Chloe will help me out. And I will certainly stop along the way to look at the chat and try to keep an eye on things. We should have plenty of time at the end as well for discussion, and I hope we can have a good discussion about Passive House. So I just want to briefly note the Passive House Network is a 501c3 nonprofit. We are focused on capacity building, on training, on connecting people, peer-to-peer knowledge sharing for designing and building Passive House buildings of all types across the United States. So we have national membership, we have chapters across the United States. We have a really good, strong relationship in California with our chapter, Passive House California, and encourage you all to check that out. We are affiliated with the Passive House Institute and the International Passive House Association. And we're really focused on education around certified passive house designers and consultants. We work closely with another organization called Emu Passive out of Colorado, who focuses on the passive house tradesperson, the builder contractor trainings. And I know they come to California as well from time to time to do training. And so we really love to see that both sides of it because, as they say, it takes a village. It takes a strong team, and the training is so important to being successful. A quick note on my background. So I am an architect by training, and I practiced for a couple of decades in New York City on the East Coast. And I'm located in Brooklyn now. And my first passive house project was this retrofit of a 19th century townhouse in Brooklyn Heights for a client that interestingly wasn't necessarily all that motivated about being super energy efficient. Uh, they care about the environment, uh, but it's not what spoke to them. And it was a real eye opener for me because I was coming at it energy efficiency, carbon emissions, climate crisis, and I had my own kind of personal logic and agenda. But they were really coming at it from another place. And the conversation was more about comfort and the health of the kids and their family and the quietness and the resilience. Um, and really finding different ways to approach the benefits of what Passive House could do. So this house was actually originally built in pre-Civil War. It was like 1849. And in 2011, we renovated it to be Passive House standards, and set it up for the next 100 years, which was really exciting. So I ended up actually perhaps a little strangely, Passive House took me out of the profession. I ended up closing my small architecture firm and really moving towards advocacy, building some nonprofits and trying to help build the movement, so to speak. So I'll refer to this project a few times along the way of certain anecdotes, like the one where it was a completely different conversation than what I was expecting. And so you have a visual here for when I bring it up. So today we'll talk a little bit about why Passive House, what's the logic underneath it. It is basic building science, and many people, and you will certainly, I think, come to that conclusion. Like, hey, there's nothing really incredibly unusual here, but it's about the intention of it. It's about the optimization and the kind of rigor of the methodology. So we'll dive into that methodology and get in under the hood and see all the parts and pieces, and then the tools that work with the methodology to really support the practitioners, the teams, the owners to get across the finish line. And finally, we'll look at a wide range of examples. So why Passive House? And I go from why to what is Passive House? So, and just kind of I guess, set up the why. Passive House is a building standard, and it's got energy components and comfort components. It applies to new and existing buildings, so we can look at retrofits like that old townhouse, but new buildings of any kind could be single family, high rise, residential, schools, factories, anything we do today in buildings could be a passive house. There's even a indoor sports center, pickleball court center going up just outside of Austin, Texas. That's like 14 pickleball courts that will be a certified passive house. So don't think it can't be done. Performance-based approach, which is really critical. This is about calculating and optimizing across for performance, for cost, for the design. And really, the great gift as I see it, and I always say of Passive House, is that it really forces you to focus on these basic drivers, this fundamental drivers of building performance, and it doesn't let you off the hook. So we may have lots of different goals around sustainability, and the ultimate result performance of the building, but Passive House is going to make sure that you deliver that fundamental foundation of what makes a great building. So, buildings, it's important, how fundamentally buildings are to us, fundamentally important that they are, that we spend, practically all our time indoors, right? They're a huge percentage of carbon emissions. Um, Sadly, to a great extent, to far more than anybody's really comfortable admitting, perhaps, they're rather unreliable in their performance. Um, and as such, they can be pretty expensive to operate and own. Um, and they can lead to pretty unhealthy outcomes. Uh, so Passive House is really taking on all of these things and trying to provide a high quality product at the end of the day, if we could put it that way. We also want to think about, we're always more and more aware, of course, of the growing extremes and the climate uh, disasters that are happening, from polar vortexes and heat waves to devastating forest fires like you experienced in the Los Angeles area recently. And so the resilience, the kind of the mitigation of climate change through lower carbon emissions and the adaptation to it in being more resilient, really sets up a building that's designed to the Passive House standard for success, at least relative success, in being able to really ride the storm, as it were, and and have a positive impact. And so with this, like my townhouse in Brooklyn Heights, there's a realization that, yeah, Passive House is about energy efficiency, and we want to be really energy efficient. But the energy efficiency is not a sacrifice, right? Energy efficiency is actually what's underlying those fundamental things that we value the most. So, and we're going to talk about how the methodology and all of this delivers it, but thermal comfort. So you're indoors, whether it's hot or cold, in between, you really have control over your comfort, and to be able to do it super affordably, that you have great indoor air quality, whether it's, you can have natural ventilation. It could be a lot of pollution outside. There could be wildfire smoke, but Passive House is really going to protect the quality of that indoor air better than any other standard. And as such, you're going to have fewer allergies. I know for myself, it isn't so much the city smog that bothers me, and the smog is much less than it used to be, for sure. It's out when I'm in the country at home. I grew up in Vermont, and my allergies kill me, and I would very like to be in a airtight environment that allowed them to keep the allergens away. So the air quality is better. Students are more alert. It's more quiet. It's more resilient and safe. As such, it's more affordable in operation, and we see generally and anecdotally higher levels of occupant satisfaction. On the owner side, you know, this is high quality construction. We'll talk about the costs in a bit. It's typically going to cost a little bit more, but it should be affordable. It should be able to work within the budget of the project. And of course, we need to be realistic and rational about how we go about that. But Passive House, there's so much in construction, and construction is so ridiculously expensive to start with. We can all say, but Passive House should not be a driver of unaffordability. We can make it work. The high quality means fewer callbacks to the contractors, reduced maintenance going forward, so durability to the structure. And we're getting really perpetual energy savings. So as we see energy supplies becoming, more strained, energy costs going up, you're going to be able to save again and again and again going forward. happy occupants means lower vacancy, higher sale price. Hard to say I don't have anything specific on it. When we have overheated real estate market with housing shortages, it's hard to know what passive house is like adding to that, but we do see passive house staying right at the top of any comparables. Uh, and so you end up with a durable, high quality asset at the end of the day. And so my pitch here is that people will come to Passive House and be like, that sounds great, but it sounds really risky. Like, I'm not sure. This is something new. Have they done it on my block? Like, that's a total New York thing. If it hasn't happened like in their neighborhood or around the corner, they don't want to know about it. Pretty common. But when you unpack it, and I hope by the end of this presentation, people will appreciate that it's actually a lower risk investment, particularly considering, where we're headed with climate, with energy, with all of these factors. The thing that I like, and I don't know how many architects are on here. I mean, if folks want to put in kind of like what your background is, if you're an architect, a builder, a homeowner, developer, regulator, certainly would be interested in knowing. Coming at it as an architect, and I know a lot of people who are, and as if you're a builder, people who care about buildings and care about design, what may initially seem like a constraint, and you're like, oh no, what is Passive House going to make me do? It's really cool in that it empowers architecture again. It really engages the structure of the building and making that form of the building a driver of performance of the building. So we're not just doing whatever, we happen to think of without consequence and say, oh, the mechanical systems are going to compensate and they'll make me comfortable and they'll make us safe. We're saying, no, this is like pre-World War II, pre-massive mechanical systems. Like, how do we go back to the fundamental building details, the forms, and execute so that the architecture is delivering the performance? And I think it can be very quite liberating in a way. We deal with gravity all the time. We don't fight that. Now we're just dealing with energy and thermal comfort in a fundamental way. Similarly, this image of the single candle in the house is basically in the wintertime, if we are hitting the passive house standard and the power goes out, you should be able to stay safe, if not entirely comfortable, reasonably comfortable with a handful of candles. It's really not much more energy than that is what's required. So being able to shelter in place in a heat wave or in a blackout in the wintertime uh, has a lot of resilience there. How it does this and a lot of the qualities come to it is that it's forcing us to go towards fixed targets and very rigorous targets. So it's not based on like, oh, we're doing 10% better, 20% better from a baseline, which may or may not fluctuate. And in so doing, what it's trying to do is decouple power and performance. Like we expect our computers to be more and more powerful and to use less energy. And the same thing with our phones, right? It's remarkable what's happened with electronics, but our buildings, by and large, if anything, they've gone in the other direction where they're using far more energy to maintain basic comfort. Uh, so in a passive house, we look at this diagram on the left, um, where we have sort of equilibrium zero in the middle between losses. So this is in a heating climate diagram, but it could be in a cooling climate or wherever. And then you need to make up the losses with gains. And you're going to have some solar gains, some passive solar. You're going to have internal heat gains from the people, the equipment, our pets, whatever it might be, and lighting. And then we're going to have to make up the rest with active heating system. And in a typical leaky house, it's quite a lot. It's quite out of balance. Our more modern houses are quite a bit better, and headed in the right direction, but Passive House really dials it in. And it dials it into a point where you can kind of let go of traditional radiator systems and furnaces that we may have in homes and look at other options, and decouple that performance. It's important to show that there may be a little bit more solar gains here, but these are not completely solar dominated, and we're not trying to make a passive solar house in the classic sense that we would think of, like looking back at in the 1970s. Great buildings, a lot of neat stuff going on, but we're really trying to control those solar heat gains and prevent unnecessary overheating, um, calculate that, and really squash the actual heating that we need to do. Electrification and zero emissions we're pushing in California, in many places. This uh, zero emissions building from the U.S. Department of Energy was from last year. I have not dared go look at the website recently. Um, but regardless of what the feds are going to do, there's a lot to be done, and these guides are certainly very important. And so Passive House has a role to play. Passive House, to be clear, does not mandate that you go emissions free. You can have fossil fuels on the site, but it encourages electrification. So it's not taking away the choice, but certain things in how it comes together, and we'll take a look at that. And the optimization is going to move towards electrification, and so certainly welcomes it. One of the things that it does really interestingly, and we have a separate talk that's just all about electrification and Passive House. Um, but what it does is kind of rethinks the relationship of the building that we're using and renewable energy production. So if you have a typical net zero single family home, purely anecdote, diagrammatically here, where the the most energy use, so it's electrified, it's all electricity, it's going to be in the winter time, right? January, December. Uh, and that's also the time of the least renewable production typically. And it flips in the summer where you're going to a zero energy. So you're zeroing out over the course of the year, but you are providing excess energy when you don't need it in the summer and you don't have nearly enough. And so you need long-term storage to actually be zero, or you need to produce a lot more to make up for the losses, what you do to make up for the losses for that storage. Um, uh, oh, will I be covering premium to ensure that net zero energy can be achieved by adding sufficient solar and adding batteries to achieve? Yeah, so I kind of bumped into this a little bit. We'll come around to it. I'll speak more to it, but yeah. So what it unpacks, which Craig wrote in the chat here, is that the way we think about net zero, which I'm kind of trying to speak to here, it's not true net zero because you have losses, you have long-term losses, and you actually have to produce more to make up for those losses. And it's kind of it's just not a terribly efficient way to go about it. And so on the diagram on the right, where we look at a Passive House Plus or Premium building in particular, it's about tuning the building to um, uh, to the power supply, to the renewable power supply. And the Passive House Institute really rates the building as in how it's tuned to what will be a 100% all renewable, all electric future, we think. Uh, and what you see is, so Passive House has dramatically reduced the demand here. Uh, so the gap is much smaller and the need for long-term storage is much smaller. And so the costs associated with that and the losses associated with that long-term storage are greatly reduced, and the overproduction in the summer is reduced. So tuning it to the reality of the situation is built into the models. Now, you can also, you're basically tuning with just a classic passive house. There's no required renewables in that case. So you wouldn't have the production part of it, but just flattening the curve of demand uh, gives a lot of resilience to the system. And of course, our power grids are under stress, right? Um, and the wintertime, in the summertime, and with fires all year round at this point. Um, and what's super interesting, and this ties back to it, um, is uh, what Massachusetts has done. So Massachusetts looked at their future needs in terms of electric grid and electrification, and they were looking at updating the building codes. And they did this study, and I have a slide from schools, but it's similar sort of thing, where they looked at the model code where they have the existing gas heating and what the strain was on the grid, right? So you have the peak load in the summertime of the electric. There's no wintertime heating load because it's gas. Now, if we just electrify that school with the model code, we're going to have the same summertime peak, but it's the wintertime that's going to blow up the grid. And it's over 4 times higher peak. So all of a sudden, and Massachusetts is looking at billions of dollars in costs from the utilities to upgrade the grid's capacity to handle this. If that same school was done to Passive House, which is the thermal code in Massachusetts, the winter peak is no greater than the summer peak, all electric. So all of a sudden, the peak load on the grid has not increased due to that building. So you don't have to increase the grid capacity for that building. So Massachusetts decided to mandate passive house and thermal codes uh, across commercial buildings in Massachusetts. In the jurisdictions that adopt it, um, but most all the population centers are adopting it, and then some, certainly Greater Boston and so forth. So really compelling reasons across kind of the spectrum of needs of why we would want to do passive house. Um, yeah, Craig, we'll follow up, definitely. It's very cool. Uh, so the logic of passive house. So it didn't come out of nowhere. It's basic building science, if a little bit on steroids. But it did come from a history of developments, right? Really from around the world, quite interestingly. We think about, of course, the time of the oil embargo in the 70s and then in the 80s uh, of passive solar and other experimental housing we have in Scandinavia and Germany, in the US and Canada. Before all of that, there was the Polar Explorer ship, which for its own purposes, um, actually incorporated all the principles of Passive House and had incredibly comfortable for a Polar Explorer ship, I suppose, ship. They didn't actually need the stove to heat to keep warm. And they had a ventilation system. They used the stove to cook, but they were quite comfortable. And in China, interestingly, is a direct link to the first modern passive house. So this Swedish academic, Bo Adamson, did the study in southern China where they weren't allowed to heat below a certain demarcation in the wintertime. And they really needed to rely on passive measures to maintain livable spaces. And that research, in some ways, directly led to uh, the development of Passive House specifically. And so this is the first modern passive house. It was built as a physics experiment in Darmstadt, Germany. Interestingly, it's not a single family house. It's a row of townhomes, I guess you could say, um, four flats side by side. It was built as an experiment. They didn't have the windows that they needed. They had to customize the windows. The ventilation system didn't exist that they needed. They needed to kind of MacGyver that. The air tightness they were going for was not kind of heard of at that point, and the calculations um, to kind of predictably deliver what they were doing, um, they were working on figuring out. And the story goes that Amory Lovins from the Rocky Mountain Institute visited shortly after and was very excited by what he encountered and was very jazzed and really encouraged them. They may have the intention already, but he was a big advocate for taking this and seeing what could be done to scale it, that it was totally applicable to industry and should be brought into the mainstream. So the Institute was developed out of this experiment. The methodology was developed and kind of formalized, and then it continues today as a research institute, tweaking and developing the standard and new applications for building types. It started, I should say, led to that doing that experiment in particular when Wolfgang Feist, founded the institute, um, has this quote, which I'll read. It says, "I was working as a physicist. I read that the construction industry had experimented with adding insulation to new buildings and that energy consumption had failed to reduce. This offended me. It was counter to the basic laws of physics. I knew that they must be doing something wrong, so I made it my mission to find out what and to establish what was needed to do it right." So a very German physicist there, and he was, we've all experienced this, right? Where you see construction projects and they're not just hitting their potential because of construction being messy, and they're not putting it together quite right. We may see it more with food, and I like to make the analogy to cooking. This great book, Salt, Fat, Acid, Heat, um, where you have these basic elements of cooking. And if you master these basic elements of cooking, you can make a great meal. And you don't need the best ingredients in the world or just the exact ingredients. You know how to manipulate it, and you know what does what and how to optimize it. And so Passive House is looking at building construction ingredients in the same way. And how are we optimizing them? What are they doing? Of course, we want high quality ingredients, but it's not necessarily so. We can do things quite powerfully with a lot of standard stuff. Passive House does have a definition. This is a tough one. They've actually, I think, simplified it to make it a bit more accessible, but we'll give this a shot. Um, Passive house is a building for which thermal comfort can be achieved solely by post-heating or post-cooling of the fresh air mass, which is required to achieve sufficient indoor air quality conditions without the need for additional recirculation of air. That is a mouthful, I will admit. But to unpack it a little bit, it's really important. Thermal comfort is right up front. We have to hit comfort for the occupants. This isn't about suffering or sacrifice per se. Uh, and that thermal comfort is going to come from heating or cooling from the ventilation system by this definition. I should say this is kind of a platonic, idealized definition. You can do this, but most buildings aren't actually designed or built this way. But it's the scaffold to make it happen. Your should be able to cool or heat from the ventilation air. And only enough ventilation air that's required for hygienic conditions. So it has hygienic or sufficient indoor air quality, but hygienic without recirculating the air. So it turns out if you have control of the space, you can have really good indoor air quality with not overpowering ventilation system. It can be a quite a low airflow and maintain good air quality. So you have a very small amount of air to carry your heating or cooling. So for all that to work, it means, it's got to be comfortable, it's got to be healthy, and we can't use very much energy. You need a great enclosure to make that work. And that's where you end up with it being an enclosure first kind of methodology, making that structure really robust. And you end up with, wouldn't worry too much about the numbers or the units. It's a really low heating demand, really low crushing peak loads. So even in a climate like Southern California, where you're like, this passive house, do we really need it here? Does it work? Um, there's a lot of evidence that it does work and it is effective. And one of the many things beyond the qualities of life in a number of ways is that it really slashes the sizing of the mechanical equipment, and allows you to put in much lower systems, operate at much lower uh, levels of energy demand. It has a very stringent air tightness test. We'll talk about that, and air tightness result. And then it has overall energy limits. So we're making a very efficient building in terms of the heating and cooling and ventilation, but we don't want to blow it out in terms of the actual usage. So we want to have efficient appliances and so forth, lighting, uh, and make sure that we're overall not using too much energy. And then we have the classic and then the plus and the premium, which was referred to, that requires some renewable energy production and requires a bit greater performance in terms of the build. You can see the overall energy demand dropping as you go to the higher level. Um, and PER is primary energy renewable. So it's not judging the building based on a zero energy concept. It's based on how well it's tuned to the future 100% renewable grid. So passive house, because if we're smashing the peak loads and the sizes of the mechanical equipment, we need to be pretty sure we're going to get there. And you need to have predictable optimization. And so the calculation and the methodology is what drives that predictability and is so important and really sets it apart. So you can do a great building just with the building code. Like you have to build better than the building code. Um, but in that environment, you could do a good building, but you could do a really bad building too. It's all over the place. Similarly with LEED, LEED does a lot of things really great. It doesn't necessarily lock down the energy use uh, sufficiently or consistently. And so you can have a lot of variability with that or other sustainability programs. Passive House kind of uniquely, wants you to hit those very specific energy targets. And consequently, there's going to be variability. There's climate variability in terms of year to year, seasonality, or occupant usage habits. But you're going to have a relatively narrow band. So going back to that house in Brooklyn Heights I did, the typical houses next door down the block, and these are small houses, 5-story, 5,500 square foot home. Really like 4 stories is one family and then a guest apartment down below, but one owner, one building usage. And the typical buildings down the street had 12 to 15 tons of air conditioning on them, which would be very typical for that type of house. We calculated that we needed 1.5 tons for the building, which is the equivalent of, uh, a window AC unit for your living room that we're doing a whole 5-story house for. Now that's scary as heck, especially when these clients, spending a couple of $1 million renovating their home. Like, are we really going to put that in? We need a little variability, right? This isn't like, we're not snipers here, or archers that can hit an absolute bullseye. Um, so we did install 3 tons, but that's a variability of 1.5 tons. And it's effectively a 75% reduction, at least in the sizing of the equipment. And I'm very happy. It was a little nerve-wracking, but it's that predictability, the calculation, the predictable performance that allowed us to do that. And that the owners, it performed well. The owners were very happy. Cost is another big issue. Now, these are high quality buildings. They're typically going to cost more. The question is, how much more is reasonable? What's affordable? How do we make it work? And certainly where we see more incentives, like financial incentives for completing a passive house project, it makes it like Massachusetts created a situation where it was more expensive to do a traditional building than to do a passive house building because the extra cost of the passive house was darn close to parity, and the incentive pushed it below the conventional cost. So it was like, whoa, okay, that's how you flip a market. Um, so on the left is a graph showing affordable housing in multifamily housing in Pennsylvania over a few years. And they studied this, and the conventional buildings are the black dots, the passive houses are the blue dots. We have the size of the building along the bottom and the cost per square foot. Now, I know this is a number of years ago, and this is in Pennsylvania, and the dollar per square foot is ridiculous. Don't try to like just keep that in perspective. We understand that nobody's building for that amount of money. It's the comparison between the two. And what they found kind of incredibly is that the average passive house building costs less than the conventional building, which I will never like sell passive house on being cheaper. Like maybe if you get the Massachusetts incentive, it'll be cheaper. But straight up, really, really tough uh, to see that. You need to be really aggressive and optimization in a way that few people are. I think what this demonstrates, though, is a couple things. One is that there's a lot of factors driving costs in construction projects. And like I mentioned before, there's no need for passive house to be the thing that breaks the bank. Um, but it does take a certain type of programming project client to make sure that you're holding to your guns and optimizing and making it work. There are a number of studies that we have out showing um, how costs are pushing towards parity. Now, single family homes are the toughest. Perhaps ironically, people think of passive house as a single family home standard, which is natural given the name. Um, but most of the passive house projects now are multifamily and other types of buildings. And those bigger buildings, it's easier to hit parity. I would say the question always comes, so I'll get there and we can discuss it later. The on a single family, 5% more to 10% more. If you're going above 10% more, you're really not optimizing, the apples to apples. And with the bigger multifamily, it's between 0 and 5. And what we're seeing is like 2% um, is what they're calculating mostly. So it should be easy for me to say it should be in the kind of contingency of the budget as you're going into construction. Um, we can talk about that. Uh, Staying in budget on target is quite doable, but really start with Passive House from day one and have it a core part of the program. With the building certifier, Passive House certifier from the beginning, learn from their institutional knowledge, get some training for the team. Doesn't need to be a lot of training, but some some specialized training will make a big difference. And then really, um, optimize all the way through. There's a Dutch architect, Sebastian Marinovaca, not Dutch, sorry, Belgian architect from Brussels, and who's really responsible for Brussels basically mandated passive houses building code, and he drove it. And he likes to talk about their aggressive optimization. He would have his passive house buildings come in 10% under what they would expect conventionally because they're really going at it. And he, would make a big joke about it because his fees were tied to the cost of the project. So it was a very terrible thing that he was doing passive house and losing money because they were less expensive. So there's some variability there. Um, Question on the costing and uh, how important it is for the builder to be a specialty passive house outfit to get fair price on construction. I would say the biggest driver, if the contractor doesn't want to do a passive house, it's going to be crazy expensive and it's not going to probably not going to be realistic. I would say the so obviously that's one end of the spectrum. It's not very helpful. That's to say that it really helps to have a contractor who wants to do it. And it's not like they're, on every corner, but and there are a growing number of them that see like that want to build in this direction and want to take this on and figure it out and do it. And so having that willingness to kind of learn by doing can be enough of a difference. Certainly, the more experience that they have, the better it's going to be, and the costing is going to be tighter and everything. But I do think uh, where it really works with contractors is where they've put it into their business plan and they're willing to essentially become a partner in some of those early projects that they're doing and investing in the training and figuring it out and getting those optimizations to then apply to future work um, and be able to do it that way. So I would say, you know, it's really useful for the contractor to have specialized training. It's not a make or break thing. It's really, I'd say it's way more driven by the builder's personality and what they want to do. That said, we do try to get them all trained because at the end of the day, that's going to be the shortcut. I would say training in general for the architects, for the engineers, for the developers. Uh, it's great if everybody involved has training. Uh, and we've had developers, we have real estate folks who've gone through our CPHD course, the Certified Passive House Designer course. Builders go through it. We've had architects go through that, also go through the certified tradesperson course. To do a certified passive house, you don't need to be certified as a professional. You just need to build a passive house that hits the metrics. Build a building that hits the passive house metrics, and you've done it. It could be certified. Uh, of course, the training, and we'll talk about this in the tools area, the training makes it a lot easier and more predictable. So not just houses, this is a garment factory in Sri Lanka that's actually a retrofit, which is one of the more kind of eye-opening projects. There are homes, of course, and I do have some California homes coming up later, but this one's in New Mexico and in Olympia, Washington, straddling you to begin with. So let's dive into the methodology. We talked about a number of aspects of this, but to be more explicit. So, and there's more to do with passive house than just these 5 key elements, but like cooking, those 5 key elements here are the primary drivers, and it's what you need to master and really figure out. So climate specific insulation levels, typically it's going to be a little bit more than code, but not necessarily. And certainly in a climate like towards Southern California, the Tri-County, um, uh, depending on what yeah the climate specifics, the building specifics, it's quite possible to get away with de minimis insulation. And actually, the renovation in Brooklyn, we didn't need, we could have below code levels of insulation and be able to hit the passive house performance. That was for a number of different things. But because you're optimizing everything, the quality of the window, the quality of the air tightness, the quality of the ventilation is helping you um, mediate all these other things, and the insulation. So um, you can invest more in one place and invest little in the other, and that's what opens up design possibilities as well. So climate specific insulation levels, thermal bridge free connections. We're going to go into more detail on all of these in a second. Thermal bridge free means a thermal bridge is where you have kind of a break in the insulation, right? Where you have a structural element going through, where you have the window frame, um, where you have the wall meet the floor typically, or the wall meet the roof. Or wall to wall at the corners, you're going to have a place where there's, in conventional construction, a lot less insulation and a lot more heat loss. So we really try to get control of that, and those calculations go into the energy model so we can be more accurate. Along with the continuous insulation. So that climate specific insulation, thermal bridge free, makes it continuous. Think of a thermos, very unsexy image, but a thermos is what we're trying to make in a way, where you're keeping the hot coffee hot or the cold iced tea cold on its own as much as possible. Coupled with that is continuous air tightness. We want control of that air. On the inside. We can have natural ventilation. We'll talk about that as well. There's no passive house police to come by and close your windows. It's encouraged actually to have natural ventilation, but we'll get there. The windows and doors are typically going to be a bit beefier, truly thermally broken, often triple pane windows. Uh, and they're, think of the windows as, providing views, providing natural ventilation, providing passive solar heat gains. But again, we're not creating like a greenhouse here. But they're also continuations of the insulation and the air tightness. So the thermal quality of the windows is super important. So think of the insulation just like a climate rated sleeping bag. A tougher environment, you're going to have more insulation. Easy, it's almost de minimis the amount of insulation that you need. The air tightness can be such a huge driver of the energy use. Um, Thermal bridge free. So again, at these connections, right? And here's an example, try to illustrate a little bit, like where often at these points, you have discontinuity of the insulation. And here is a diagram showing the floor and the wall. And you have masonry construction. And here's a piece of masonry. It's not thermally very good, just regular old brick. And so you have a break in the insulation layer, and you have a thermal bridge. Um, it may work on a comfort wise, but on an energy perspective, uh, it could be problematic. And you could also have a comfort issue, uh, or a hygiene issue, which we want to look at. But something like this, it doesn't have to be rocket science. Just replacing that a thermally poor brick with aerated autoclave concrete, something that's performs a bit thermally better can be enough to drop that connection to make it thermal bridge free. So uh, these are the sorts of things that we look at when we do this, because what we want to avoid, in tougher climates and cold climates where you have poor thermal performance, um, we don't want condensation. We don't want mold. We don't want the building acting as a radiator to the environment. We want to keep the conditioned air, the conditioning in the space itself. Um, we want to align that insulation. So you can see the thermal lines coming through here where this door is aligning with a break in the slabs with insulation going to the exterior insulation on the wall here, and then connecting to the exterior insulation here. So all these things in terms of the detail and how things are aligned and come together is something that we look at carefully. So air tightness, and some of our California friends like to call it smoke tight, to emphasize the fact that it really is dramatically different in terms of when you have really poor outdoor air quality. You can't overestimate the importance of having that airtight enclosure and having control over it. It's probably an extreme example, but an important one. So the Marshall Fire a couple of years ago in Colorado, in Boulder County, there were a number of Passive House people there, and we did a lot of work in support after. Um, One Passive House person who had renovated their home to Passive House standards, had an airtight home. The fire came to within 100 feet or so of his home, just uh, just away from their sort of street. Their neighbors, so him and his neighbors were saved. The structures were saved, but his neighbors had tremendous smoke damage from it. He went back to his house and he couldn't smell smoke inside. It was like just kind of unimaginable difference with that. Um, Air tightness also helps reduce moisture damages, massively reduces heat loss, helps control the humidity. And I know in your neck of the woods is probably, you don't have the toughest climate. So some of these aren't as necessarily as uh, uh, pulling, but bringing these together and being able to dial it in, it allows, to have control, even if it's not the most extreme. Keep that outdoor pollution out and have good indoor air quality. So, the prerequisite for having really quality control over something is to have control of the thing itself first, right? And so the way we have control of air to maintain high quality is to get control of the air and get control of it by being in an airtight environment. And then we can quite efficiently maintain good indoor air quality. It helps, think of it too, like a windbreaker over a fleece sweater, cool autumn day where the wind is blowing and it's still chilling you down because the wind is moving right through the sweater. Um, it just really helps optimize in a bunch of different ways. So we've had the continuous insulation, the thermal bridge free construction, the air tightness, and now the windows and doors are continuations of those insulations and air tightness. So they're often triple glazed, triple gasketed, truly thermally broken. They can be made of a whole bunch of different materials, metal, wood, UPVC, um, uh, historic styles are possible. There are many, many possibilities now. But the thing is, we want these to latch airtight closed, um, and we want them to be operable to allow for natural ventilation. Whether it's double pane or triple pane is going to be oftentimes a comfort criteria calculation. We'll talk about that in a second. Oh, literally the next slide. One of the things of one of the things that drive that with passive house and differentiates it from normal construction is when you have these temperature differentials, so it's cold outside, um, the temperature of the glass can drop significantly, and you feel it pulling the heat off of your body, and you need to overcome that. It causes convective currents, and you need to overcome it by having perimeter air conditioning, radiation, heating and cooling. With the passive house, we want that based on the design temperatures, exterior, um, we want to have that temperature of the glass be relatively close to the operative temperature of the space and the other surfaces of the space. So you have a much more thermally calm space that you're in. And with that calmness, you don't have the convective currents, you don't have the stratification that you do in typical spaces. So you don't need to overcome it with perimeter heating and cooling. You can pull it back to the interior, still supplying those perimeter areas, but not at the exterior wall itself. So the quality of the window that install is very important. The remedy for mold in colder climate zones with passive house. So what we want to do is just make sure that the construction, the assembly, whether it's the window assembly, the wall assembly, is robust enough insulation wise and air tightness wise so that we have relatively high humidity. Say we have in a passive house, because we have control of the space, we may have indoor humidity in the wintertime of 40% or more. 35 to 45% relative humidity. And so you want to make sure that those internal surfaces, right, the internal surfaces of the exterior wall or roof or floor are warm enough so that interior humidity isn't going to condense or isn't going to cause mold growth. And so we calculate when we do, we'll get to, no, actually, the thermal bridges, when we just talked about, the we're calculating these different joints and understanding what the, you know, what the energy loss is at these joints and making sure that that coldest point would be at that corner. This looks quite warm, actually, is warm enough to not cause any mold growth. So it's really zeroing in on that and doesn't take anything for granted. And that's why we develop like kind of standard folks in architecture firms and builders will develop kind of a catalog of their standard details. They know what works, they know what they can repeat, and for the climate and what they'll be able to use. We're still calculating, but they're basically cycling the calculations at that point. All right. External shading is the best. Well, let's say shading is considered an integrated. We can all, you know, add interior shading if need be, and people will install interior shading. But to the extent that we can, in considering the exposure of the building, comfort, energy use, we're trying to go beyond that a bit because exterior shading is much more effective than interior shading. And if we can make it part of the architectural design, and it can be as little as just having that recess, you're providing enough shading to prevent unnecessary overheating. If you're in a heat wave, an extended heat wave, or it's just super hot out, you're going to need air conditioning. These buildings are not meant to be unconditioned. We're just trying to absolutely minimize the amount of cooling and heating that are needed. So architecturally, we may look at it. We may look at it in terms of the landscaping, um, but incredibly important to consider. At the end of the day, you know, it's about using the space comfortably, right? You want to be able to sit at the window on a cold winter day and be comfortable, and you don't have to have a heater underneath you. Um, and you know, you can have decent amount of glass, you can have views, you can have light, you can have natural breezes coming through. We just want to be really intentional about it, and do it because it has a purpose to do it, and not just because we want to wrap our building in glass. Uh, you can wrap your building in glass too, just a lot more tricky, a lot more expensive. So with those four things, you know, one, two, three, four, that's all enclosure. This is all about building this great, beautiful, high performance thermos. And then the ventilation is brought in. Now, I keep saying it, natural ventilation is absolutely to be a core ventilation strategy and to be thought of and put into the design. What Passive House says is we can't count on natural ventilation. And actually, natural ventilation from data head to head produces pretty poor results compared to mechanically controlled ventilation. And certainly when you have a lot of pollution outside, you have smoke outside, you want to be able to provide ventilation in a controlled way. You don't want to rely on the weather for it. And if it's really hot out or really cold out, you don't necessarily want to have to open a window to get fresh air. So mechanical ventilation is a must. We supply it. So, you know, all buildings have mechanical ventilation. They're just typically exhaust only in bathrooms and the kitchen. It's intermittent. We're relying on a leaky enclosure to bring the air through willy-nilly. We don't know if this room or that room is really getting ventilated, and it depends on the weather as to how well the building is going to be ventilated. Here, we're bringing in it fresh air 24/7. It's at a relatively low volume because we have control of the space. We're filtering the fresh air. We're supplying it to all the served spaces. So the bedrooms, living rooms, classrooms, offices, conference rooms. Make sure their rooms are getting the fresh air that they need to maintain good air quality, hygienic conditions, healthy conditions. And we're exhausting from the service spaces, the kitchens, the bathrooms, the hallways, utility closets, and laying it out in a way so that we know the building is getting completely ventilated in a very predictable way. Because it's running 24/7, you know, we want it at a relatively low volume. This is not air conditioning like blowing. We also want it to run quiet, and we don't want to lose that much energy, right? So it has a high efficiency heat recovery, and we can recover now over 90% of the heat that's being expelled and bring it back into the incoming air. So that helps keep the interior hot in the winter and cool in the summer. It can also do some humidity recovery too, if that is needed. That's the passive part. So it's just two fans, right? It's simple energy efficient fans in the unit that are pulling the air in and out. We're balanced, so we're not pressurizing or depressurizing the building. Uh, and it has these cores in the middle that are uh, counterflow cores and specially designed, so we're not getting any contamination between the exhaust and the supply, but we're getting all the energy transfer. Uh, and so they can be really super efficient, and they're a big game changer in terms of the ultimate model, as well as just providing fresh air. You have to change the filters. So one thing, you know, they will typically we're seeing changed quarterly, but if you're in a heavy use, like um, it may need to be more regularly. They can be washed and and changed, but bought new after, you know, several rounds. Could be centralized or decentralized. So in bigger buildings, we're typically going to have a centralized unit um, and distribution through the building. If it's a single family home or apartments or units of some kind where they want that unit by unit separateness, it can be done that way too. So, you know, really one of these aspects with the thermal quality, calmness of the building, having that clean, fresh air um, just makes it so much more healthy. So internal heat gains um, uh, are super important as well. And the internal uses, the heat gains, and the ventilation requirements are put into the calculation and is part of that energy balance that's going to allow us to size the equipment properly. Is ERV, HRV is better to be inside or outside of the building? Well, typically, you know, in a smaller residential building, it's going to be inside. Bigger commercial buildings, it's often outside, but it could be inside. It could be either way. It doesn't really, so in a single family home, it's I mean, I don't think I've seen it. I've seen a retrofits in the Netherlands where they're kind of outside because of the way they did it. But basically, 99.9% of the time they're always in within the home. They're in the utility closet, in the laundry room somehow, hopefully near the exterior wall. So the key thing, and this slide will sort of do it, is that you've got the heat exchange happening near the exterior of the building. That ductwork that goes from the unit to the exterior is effectively outside because the the air that's coming out of the unit is outside air effectively, right? It's back at the outside conditions. And so you need, or the air coming in has not been exchanged yet. So those ducts need to be very well insulated and sealed against potential for condensation. If your unit's outside and it's coming in, the ducts between the unit and the thermal enclosure need to be well insulated to do that. Within the conditioned space itself, the ducts don't need to be insulated. Does it affect what affects the efficiency is if the ERV, HRV is a long distance away from the enclosure, so you've got a lot of duct run that's effectively outside. So you have potential heat loss or heat gains from those ducts to the interior space. So you want to just make those duct runs as short as possible for maximum efficiency. So we do the four enclosure things, we do the ventilation, we're thinking about optimizing the internal heat gains, the ventilation requirements, and then we right size the heating and cooling systems. So that's the order of operations. We don't start saying, oh, we need 12 tons of air conditioning. How do we make it fit on this house? We calculate what we're doing to it and then right size. And typically what we can see is about a 75% reduction in that heating cooling size. More efficient distribution because we don't have to go out to the perimeter. So architecturally, we may be adding a few, more inches on the outside on the footprint of the building, but we're also getting some inches back because we don't need the perimeter. We also don't need to be softening out to the perimeter. There are certain architectural advantages to be able to pull it all back to the core. And with the reduced loads, it's easier and not uncommon to go all electric. And as we do that, a big part of this, we're talking about renewables and the standards there and, net zero and all of that. Renewables, great. Smart systems, maybe great as needed, depending on how complicated the building is. But we want the smart controls and renewables to come at the end. Like once we've figured out how the stuff, all the passive stuff is really going to work well, so that the renewables and the controls are enhancing high performance, not compensating for poor performance, is really the setup for that. Um, yeah. So let's see. And then all of this is going into the energy model. So the passive house planning package, PHPP, um, it's uh, it's a model where we're putting in the five principles and more, and then we come out. Now the heat demand is the big driver, but it also, tackles the cooling, the ventilation, overall energy, and all of that. Um, and but this is where we get that predictability, that optimized design, and we get something that is applicable around the world. Like this is just fundamental physics, and we see it applied in different ways around the world. Do the ductworks go through the attic or through the wall? They could go through either. It doesn't, it could go through the floor too. There are buildings where the ventilation unit could be in the cellar, or it could be on the ground floor and go out and around. The systems will use, um, now I'm blanking on it. They'll use, you know, uh, tubes, earth tubes, to bring in the air and actually temper the air with the earth temperature before coming into the ventilation system in the cellar. So really anything's possible there. So let's look at the tools to make this happen. And then we'll look at some buildings. So certified professionals, and we'll give a plug again to the CPHD and the tradesperson training. Again, you don't have to be trained to do passive house, but it sure does help. We do have our next specific cohorts kicks off July 1. It's on demand, and it's a mix. It's online, of live online and on demand, and we provide a lot of support along the way and get you through the exam, hopefully successfully. The good pass rate if you study and work at it. And happy to talk if you have any questions about that. I know 3C Ren has some nice incentives regarding that. And then the tradesperson. Also, hopefully EMU will be planning to come to your neck of the woods sooner than later. I looked earlier today before I came on. I didn't see anything planned, but maybe I'm sure they will be coming again at some point. I,
Emu, I'll chime in. Emu is coming late summer, early fall. So I'll add that link to the
Fantastic.
chat as well.
Yeah, great. Thank you so much. Um, so yeah, totally worthwhile, and they're both, a lot of fun, if we can say that. It's exciting stuff. Um, we have certified professionals, we have certified components. So the Institute has very specific performance requirements, right? They know and how it goes into the energy model and to get that predictability. So key systems like the construction systems, so like opaque wall systems, windows, the ventilation system, curtain walls, attic staircases, all these sorts of things. You don't need to use a certified component to do a passive house, but the certified components are another kind of thing that makes it easier. All along the way, in terms of designing and building a building, there are going to be decisions you make that are going to make it or harder or easier to hit the performance goals. And you kind of have to juggle like what's the right mix to make it all work. But huge lifesaver, and a lot of the components that are certified are already populating the PHPP, so you can find them and select them. If you're not using certified components, sometimes it can be a little tricky to get the information that you need because the manufacturers may think they have it, but they don't have it, and it can be quite a bit of back and forth. Still doable, but a bit more aggravation perhaps along the way. These certification levels, as we were discussing, the classic, um, high performance building, and then we've got the plus and the premium. And each of these, as we discussed, has a renewable requirement, which increases, and a performance requirement that increases. Interestingly, we're talking about grading it against not a net zero, because that's against the square footage of the building. And what the classic net zero calculation does is it it kind of favors low-rise building, right? It's a lot easier to make a two or three-story building net zero than a 10-story building. So what the Institute did was say, we're not going to calculate it that way. We're going to calculate it in a number of things, but in regards to that, we're going to calculate it on the projected footprint of the building. So how much earth does my building take up? And how well am I optimizing renewable energy production based on the square footage of this precious piece of earth? So whether it's 1 story or 100 stories, the renewable production is based on that projected footprint. Interesting. Um, let's see. And the retrofits also have a series of the standard classic retrofit plus a premium, similarly tying in renewables. This is a Marcel Breuer classic brutalist building in New Haven, Connecticut, right by Yale, and that's been converted into a hotel, certified. Enerfit, the retrofit standard, there's a whole other presentation on this, but there are a couple of ways of approaching it. You can approach it from the performance method, which is kind of the classic overall energy demand. And if you're in a tougher climate, it loosens up the demand. You're in a warm climate, so it keeps you right at where the same standard is for new construction. Um, and why it does for tougher climates is, for an existing building, there are lots of things you can't control. And so it makes an allowance for that while still going after a whole bunch of the kind of high performance qualities of it. There's also a component based method. So you don't do it by the total uh, energy demand. You can say, oh, this 4.75 is still too tough with this existing building. You can look at the different assembly pieces. These still go into the energy model. You're still calculating the overall energy demand and the primary energy renewable, but it can be an easier way. So there's more flexibility built in there. It's all calculated in the PHPP. This is that spreadsheet. There are a few other tools to help you along the way. And this is when I think we'll make the pitch for the in-person airtightness testing training. This is a key element of delivering a passive house. It's one of two physical tests. So a whole building enclosure airtightness test. This is the Cornell Tech building in New York, which is a 24-story building. The 0.6 ACH50 is the passive house standard goal. And they built this enclosure so airtight that this was the only blower door that they needed for the building. There's just one setup. I think they did use the two fans, but just the one setup, which is kind of incredible. They actually hit, if I'm remembering correctly, 0.14, which is dramatically less than 0.6. So super important to be able to do this. And yeah, as Chloe just dropped in, May 2nd in Santa Barbara, there is an in-person training, site blower door training. So definitely check that out if you can. Um, Building certification is super important. We could talk about it in a number of ways, but I think the key thing to appreciate is that Passive House can totally work with the traditional construction schedule and sequencing. There are just a couple of things that you want to be more um, cognizant of and try to lean into. And one is to make some of the, well, to make a number of uh, construction decisions and design refinement decisions earlier than later. You want to be in design development, thinking about things you may typically be thinking about them in construction drawings so that you're working out those thermal bridge free connections as you're developing the design, um, and getting them tested by, if you're the consultant, you're testing them, or having a passive house consultant test them. Certifier may review them to see how it's working out. Because when you come into construction documents, you don't want to be having to undo things and redoing them just based on the energy, um, excuse me, energy performance. Um, we often argue to have, like, we are naturally think about having a contingency, a buffer in the cost of the building and the budget of the construction cost, to also have a buffer in the energy budget. So we're going for a certain energy number at the end of the day, a couple of different numbers. Um, that we maintain 20% buffer in schematic design, 10% buffer coming out of construction documents. Uh, there's another physical test that happens on the site. Now you have to hit the 0.6. That's not debatable. And if you can hit lower, it really helps with your energy model because you can. The certification is based on the PHPP, the energy model, and the drawings and the details and the specifications as built, not as designed. Hopefully, if you design it and you build it as designed, no problem. But if you're substituting things in and out, you need to verify those against the energy model and um, test the blower door for the whole building and the ventilation testing and balancing to hit the numbers with that. Um, yeah, I'll leave that there. It's a whole other, the verification and everything is another presentation as well. But to say that it it moves with the construction. Yeah, here's the PHPP. This is a lot to go back and forth on. But you're basically, I would say that the point here is that the PHPP, the energy model, you're using it as a design tool. You do not want to be like, oh, we're going to design for a month and then we'll send it over to somebody and they're going to run the model and tell us, whether we're okay or not. As you're doing design iterations, you hopefully have somebody in-house, or you're working closely with a consultant who can run the iterations as you're going through, and you can run different scenarios in the model to see what effect things had. If I change the percentage of glazing on this wall, or change the specification of the windows, or whatever the form, shape and specifications that may be in play to make sure that you've got a handle on it. So you want to go back and forth um, a fair amount, but have a fully complete energy model, coming in, well, coming out of construction documents, certainly, and going into construction. The last thing I would note about that is I need to update these two slides. The I will note in the going into construction, there's something called design assurance that you can get. So you take the construction documents and you take the energy model and you give it to the certifier and say, you know, can this be certified? And they'll review everything and produce a letter uh, if it if if it looks like it will be certifiable, that it is certifiable. That so that when you buy out the project that you're buying as an owner, it's really critical to know that you're buying out a project that is certifiable at the end of the day. And then, of course, it's in the construction, it's a matter of holding that spec or making sure that substitutions are truly equivalent. So let's look at some brief examples, a number of examples. So we have a growing number of high-rise construction. A lot of it's residential, but this building in Boston on the right, which was completed a year and a half ago, um, is the world's biggest office certified passive house office building. Um, and it's wrapped in glass. It's not all vision glass. Uh, and it's certainly, commercial high-rise curtain walls not cheap to begin with. So I don't think it was a giant delta, but um, uh, you know, apples to apples, but definitely a lot to make work there, but doable and possible. And they wanted to deliver an office product on the market in Boston that was hitting all the marks in sustainability and quality of occupant experience. Affordable housing we see very big. Where in New York, in Pennsylvania, in Massachusetts, and growing number of other locales where real incentives have come online. And it's really gratifying to see it because it's allowed, and there has been a bit of a progression where I think a lot of housing advocates in the earliest days were, if not downright hostile to the idea of passive house coming into affordable housing. They're skeptical because of the fact that it would cost a little bit more. So the equation is then you must be taking away money from more housing. Um, but I think it's been overcome the idea, the realization that it's really not that much more money. It's de minimis in a lot of ways. And you're delivering high quality housing for these people so that they're really getting the benefits. Um, and and the community's getting these long-term benefits that are resilient buildings, shelter in place buildings. They're not filled with mold and a better quality of life for some of the people that have need it the most. Um, and so it's been a great alignment. And we see all kinds of design in passive house. So, and this was a wonderful thing. This is in the UK, affordable housing that won the Sterling Prize. So like the biggest design prize in the UK a few years ago. Museums. Um, This one is in Germany or in Austria. Sort of says it right there. It's in Austria. Here we have Herzog de Meuron doing a project in Vancouver. I'm not sure where this is. I saw something in the paper where the whole project blew up. Not for Passive House, but just the usual kind of overambition and construction costs and all of that. But it's doable, you know. Buildings of complexity and different usages. Government buildings here, typically, uh, you know, typical sort of glorified office buildings, but we have the Belgian and the Dutch embassy in Kinshasa, Congo, passive house, and in Brussels where they've mandated passive house. This is the building on the environment, Brussels Environment Building, which doesn't look like it could be a passive house per se, but can hit the performance targets. So a lot of things happening there. This is an archive building in the UK where you want absolute, you know, uh, environmental control inside with the humidity and the temperature. And they can do it in this, like use flat line and very little energy. Um, Recreation and emergency services. So on the right is the firehouse in Vancouver, and on the left is a big public recreation center in Exeter. I think it's something like 4 indoor swimming pools and different uses um, that are certified. Um, oh, I doubled. I doubled with the embassy somehow. Well, here's an interior shot. Um, and then this is a education center in South Korea. That's pretty amazing. And we get another look at our hotel here, a little bit more information. So they did a lot with renewable energy on the site, on the building, but in the parking areas as well. It's right, there's a big highway 95 is literally just like right here out of view going by, like a 8, 9 lane, 10 lane highway. And the rooms are absolutely quiet. You don't hear the highway there. Beautiful project. University building. This is the opening shot of the presentation. This is uh, what is it? The College of the Atlantic in Bar Harbor, Maine. And then this project that's just finished, opened for students this past fall. This is in Brooklyn, down on Flatbush Avenue. Um, and it's a high school and a primary school, two schools together. And there's a huge all electric building that's not passive house, but the developer's actually planning the next phase of the project behind it. I should have put an image. It's going to be a 60-story all electric. They say passive house. We'll see what happens. And some houses. We can do houses too. Colorado, we have one in Maine, Los Angeles. Did I not put the northern? I have to get more California examples in here. Sorry. But there are a bunch of passive houses in California, of course. And here's the plug. There are, well, 3C Ren has got the financial incentives. Usually there's a range of financial incentives that are possible that we have. So if you know somebody that doesn't get the 3C Ren, this doesn't qualify, that may want to take it, there's a whole bunch of others that are possible. So that's my presentation. Thank you. And we've got some closing slides. Do we do the closing slides first and then we can have a discussion, or?
Yeah, let's go ahead and I'll do the closing slides really quickly. And then there's a few questions in the chat and we can see if any other questions pop up. First, I just want to pitch everyone on this really great resource that 3C Ren offers called the Energy Code Coach. If you're in the Tri-County region and you have any questions about the Energy Code Title 24, you can reach out to us here either online or over the phone. And we partner with Imbalance Green Consulting. They're out of the county of San Luis Obispo, and they will provide quick and really knowledgeable responses to any question you might have about the energy code in our region. That's a really great resource. And then lastly, before I pass things back to Ken, I just want to thank everyone so much for coming today. I want to thank Ken for a really great presentation. I've listened to a few recordings of this presentation before, but it's always great hearing this information again. It's such an interesting topic, so I really appreciate you being here. And so a few things before I pass things back to him. As a reminder, we will be sending a survey out to you all in the next few days. Please make sure to take this if you like the training. It really helps us out. We're also going to be distributing learning units to folks who requested that when they registered. As a reminder, please just make sure that you email Danica. Her email is here under continuing education units. If you have any questions about receiving those, make sure you reach out to her. You're going to be getting these slides in the next day or two, so you'll have access to this email there as well. And we also have a lot of really great events coming up. I'm going to go ahead and just put the link for all of our calendar events in the chat so you guys can click on that and peruse. But we have a lot of great passive house content specifically coming down the pipeline. June 29th, we have another training with Ken. He'll be back to talk about mechanical systems. And then we also have, as was already mentioned, these two different ways to get passive house certified. We have EMU coming in late fall or early fall, late summer. And that link just went live. So that's probably why you didn't see it when you checked earlier, Ken, but I put that in the chat. It's also going to be on our website. And then we also have the passive house designer consultant Pacific Summer cohort. So definitely sign up if you're interested. If you are in the Tri-County region or if you work in the Tri-County region, these are all free for you. So definitely take advantage of that if you're interested. And if you have any questions, you can reach out to Danica. You can reach out to info@3cren.com or .org, and we will get back to you. And with that, I'll pass it back to Ken to answer any lingering questions.
Great. Now, should I stop sharing or I think so? Let me. Here we go.
And then we had a couple of questions in the chat,
Yes.
so we can start
Yep.
with those.
Yep. Absolutely. So, first question from Queen Antonia. So, you know, I would say the main difference between doing the training with us or through FIAS is that our training is more, I would say it's more solidly in the fundamentals and getting the kind of like clear-eyed bedrock passive house knowledge. FIAS, you could do good buildings too, of course, but they tie in a bunch of co-requisites that have nothing to do with passive house. And my personal feeling is that it kind of confuses things unnecessarily. And if I may say, it's hard to know where passive house stops and starts. Um, and, not that doing the other programs are a bad thing, certainly do whichever programs make sense for your project. But to just be really clear about what's what and really be able to master it in a way. I think it's more straightforward. None of it is totally straightforward. It's complicated. It's building science. It's simple in a way, but it's also complicated in a way. So that's how I would address that. Um, any of these buildings net zero energy? So certainly any number of the like single family residential. So it showed and I apologize, there was only one interior shot of the house in Los Angeles by Christian Knopfel. And that's net zero building. There are a number in the Bay Area that are all net zero buildings. You're basically lowering the um, the demand to an extent where putting a very modest PV system on the roof will zero it out. Um, it's it's not hard at that point. The bigger buildings, they're really not typically trying to zero out. And again, in terms of passive house, they're not being rated based on being zero. They're being rated based on a measure of optimization against a future all renewable grid, which is a little bit esoteric, but there's a whole other class on that. Incentives for Bay Area residents. Yes, so PG&E does have incentives as well. And so you should definitely look into them. If you go on our website, I should drop the link in. I have my act together. And go under education and financial incentives. Let's see here, training financial incentives. I'll drop the link in. Um, there's a breakdown of different regions, states that will have a link to the PG&E as well as the 3C-REN and others. And also other incentives for like different groups of people. We have a incentive there. You can't double dip, but we have incentives for veterans and teachers and students and so on and so forth. That's that. Yeah. Any other questions? We're going to have an open house. We're going to have passive house open days in California um, at the same time as the USGBC California conference in San Francisco. Um, I want to say that's May 22nd. Not positive. We're just in the middle of planning it. We'll be announcing it. So we try to somewhat regularly have open houses. And so we want to do that there. We're doing a number of things around I'll just mention the Marshall Fire in Colorado a few years ago. We, with the Passive House folks there, we kind of gathered and worked with Excel Energy there and in support of the rebuild. They lost, I think, over 2,000 buildings in that fire. And of course, after the Los Angeles fires, much, much bigger. Uh, we are looking to ways to support, and we have a committee um, uh, uh, on climate disaster kind of rebuild and bring Passive House resources and working with Passive House California and local practitioners to share information and do outreach so that people can have a better idea of what options they may have um, in rebuilding. So you keep an eye out for those things. And we're still in the middle of developing a number of things, but I could give you under resources, it is this. I don't know that hmm, yeah, so this is under development, but there are some things there. PG in the application plan doesn't seem to work. We'll look into that. Let me see. Any other questions, thoughts, comments? Oh, yeah, they're currently not accepting responses. Okay. So the spring cohort just started. I think they're in the process of regrouping and deciding how many people they can support and that sort of thing. So hopefully that will open. I would keep an eye on it. And if you sign up, I'll make a pitch to sign up on our website for our newsletter, and we'll certainly be trying to keep people up to date in that. Great. Anything else? Well, I really appreciate being here today and being able to present to you all. Feel free to let me put in my email into the chat. Ken at passivehousenetwork.org. I think I spelled that right. There's my email. Feel free to reach out if you have any questions and going forward. And if you don't see that PG&E thing pop up, we'll try to find out. But you can always email training at Passive House Network too. Becca, who's our training manager, will know more than me.
Awesome. Well, thanks everyone so much for coming today. Thanks, Ken, for being here. And if there's no more questions, I think we can all get going. I'll end the recording, and I hope to see you guys all soon on another event or training we have.
Right.
Bye.
Thank you so much, Chloe. Thank you, everybody.